Hi and welcome to the exam collection where we do videos on about 6 questions to help you revise for your GCSEs. They are really just nice, short, snappy bits of revision. Should take about 30 minutes at the most, depending on your confidence with the questions that we have. All right, so these are all calculator questions. You hit pause, you have a go, and then you press play to see the solution. So hit pause, and when you're ready, press play. Okay, so these questions aren't massively loved, and it's just about picking apart the information. So we've got red pens and blue pens in a box. We know there are 12 red pens. The probability of taking a blue pen is 2/3. So I've got information about red in one form and information about blue in another. So really, I need to get the connections. Here, where they're telling me I've got 2/3 blue, that means that I've got 1/3 red. And here I now have some useful information. If a third is equal to 12, then 2/3 is equal to 24. I want the total number of pens, which would be 36. Okay. All right, now that has come from a non-calculator paper. Sometimes we do tend to forget that things like that can come up because they are much more common on non-calculator, but they've only got to put that word show that in front of something, and that's it then. You've got to show every stage. You really got to show you have a method. So hit pause and press play when you're ready. Okay, so this is a takeaway question. So I have smashed window as my method. However, smashed window is for fractions, and at the moment I have mixed numbers. So my first job is to get those into just fractions. They'll be top heavy, but I can't have mixed numbers. So I am going to be working my way around. That is what my eyes are doing. So 2 times 7 is 14 plus 1 is 15. So 15 is on the top. The denominator does not change. I repeat that process. And I end up with 14 over 3. And then I can put those fractions around my smashed window. 15 over 2 along the top, 14 and 3 along the side, multiply in. This is always your denominator. And then again, check in with that question. It's a takeaway. Make sure I haven't forgotten what I'm doing. And that will give me 17 over 6. But let's not lose sight of what we're being asked to do. We want to show that it equals this, which means I now need to take that back into a mixed number. 6's into 17 go 2 with 5 left over. Okay, next question. Hit pause and press play when you're ready. Okay, so for this question, with angles, there is always more than one way to move around a diagram. So the way that I'm about to do is maybe different to you, and that is absolutely fine. One of the things that we've really got to spot is give reasons for your answer. So my top tip is to just do that as you go. Okay, so the first thing that I'm going to do is I am going to look here. That's what they want me to find. And I could use angles on a straight line with this one here if I knew what that was. So that would be a handy one to find out. I've got some information up here, so it's very likely that's going to help me. If I show that, I can see that full circle, angles around a point equal 360. So 360 take 250. That's going to give me 110. Mark that on the diagram. It's always really good to do that. Give a reason before you move on to the next thing so you don't forget to do it. So angles around a point equal 360 degrees. And then you can move on to the next thing. The next thing being the triangle that I can see here. Triangles add up to 180. So if I now do 180, take away my 110 and my 38, which is a total of 148. I'll get 32. So that's putting 32 in here, and remember your reason. Okay, last but not least, we can finally use what we spotted right at the very beginning, my angles on a straight line. So 180 take away 32 is equal to 148. And my reason is straight line equals 180 degrees. Okay, now there is a slightly different fact that you could be using. This would be the most common route, so that's the one that I've chosen to do. Okay, next question. Hit pause and press play when you're ready. Okay, so probability tree diagrams, really, really common. So we've just got to read carefully and check in with the diagram we've been given. So we've got the probability that Kelvin arrives on time is 0.7. Kelvin is here, which means this part of the tree diagram belongs, spit it out, belongs to Kelvin. So he's got a 0.7 chance of being on time, meaning he's got a 0.3 chance that he will not. These always add to 1. Now I can take a look at this line where being on time is 0.9. Okay, so that is all of this section here. So being on time is 0.9. So 0.1 for being late or not on time. And that's not going to change. That condition doesn't change. So that gets repeated. We're then asked to work out the probability of them both arriving on time. So that would be this pathway. That's on time, that's on time. As I travel along that pathway, I can collect up my probabilities. I've got 0.7 and I've got 0.9. I just multiply those to get my answer. So 0.7 times 0.9 is 0.63. Okay. Next question, hit pause and press play. Okay, so this is a particularly mean question because all they've done is give you some squared paper and you've got to draw literally everything from scratch, even the axes. Before we bother with the drawing of the graph, we're going to need the coordinates. So if they gave us an axis, it would make life a lot easier. If they don't, it doesn't actually change the first step. The first step absolutely is finding those coordinates. So if you're being asked to draw a graph, you are going to need a table of X and Y values because those are going to be your coordinates. Okay, so let's just bring that down where we can see it. They've told us very clear that the X values are going to be -2 all the way to 3. So those are the numbers that we're putting into the table. The rule is what helps us find our Y. Y is going to equal 2x minus 3. So my rule is 2x minus 3. Let's say we are working on this X value first. That means the X is going to be 3. So 2 times 3, replace the X with the 3, is 6, take away 3 is 3. And that would be one of my coordinates that I plot. So I would have the coordinate 3, 3. I'm going to repeat that with the 2. So it's 2 times 2, take away 3, and 4 take 3 is 1. And that's another coordinate that I've now got, 2, 1. 2 times 1 minus 3, which gives me -1. And what you should be noting is that X value is changing each time, but the rule, you know, the other parts of the rule are remaining the same. I can now start to see a pattern. This is going down 2 each time. So to save me doing all that work, I can now just take away 2 take away 2, take away 2. And then I have all the coordinates I need to plot. So my next job is just setting up those axes and plotting them really, really carefully. So I've already done that. I'm prepared. So that's what my chosen axes look like. I didn't have to go up in 2s. There's no rules here. I just chose to. As long as they are equal at each step, then that's fine. These are going up in 1s, but it's equal every time, going up 1 every time. And then you must, when you've plotted those coordinates, remember to actually draw the straight line. Okay, that is more common. I thought I'd just show that in case anyone was starting to panic and think, oh my God, I don't want to do all of that. It's very, very unusual to be expected to draw it from scratch. So that's more of a classic question. And I'm going to just do that one next time in a different video so that you get to practice it again before those exams. All right. Now, this is a really, really wordy graph question. And we are asked to interpret graphs, and that type of question can change in its appearance all the time. So it's quite a hard one to prepare for. What I'm going to suggest you do, because equally what's difficult is you don't have a copy of that graph. So what I want you to do is just kind of sketch it or write down what you would do so that when I go through this, you can go, yep, that's what I would have done. Yes, that's what I would have done, and so on. Okay, so have a really good read through, hit that pause, obviously, try and think about how you would answer it, and then press play when you're ready. Okay, so really, really important that you just take a question like this step by step. So the first question, if you take in that it's a 1-mark question, that should tell you it's not likely to be the most complicated. It should be fairly straightforward if it's 1 mark, because there's no working out. So it really is just reading the graph. It says, find the cost of hiring the chainsaw for 6 days. So you're just going to come down to the days, find the 6, and then I would recommend drawing a line straight up, hit the line, you come straight across, you come out pretty much between that 15 and 20. So I would say £17.50 would be that cost, okay? This is where it starts to get a little tricky now. You're being asked to find out the daily rate. So we know where it's starting at 10, that there's this flat rate. It's going to, before you've even taken it out for 1 day, you're at 0 days and it's cost you £10. And then with each day, there's a steady cost involved. And that's what we need to work out. And that comes from looking at the gradient of the line. So I have done this already here. So the blue line you can see is me answering part A. Now the red line, when you're doing a gradient, you are working on a right angled triangle, and the size of that right angled triangle really doesn't matter. I personally recommend making really the biggest possible triangle that you can, because it's just easier. All right, if I'm stretching from here all the way to the end, then I can clearly see I've moved a distance of 12. I'm not counting squares. I'm not trying to work anything out too difficult. And then straight up means that I'm making my right angle, and I then just need to make sure that I've got the difference between these two, which is the 15. So you've got your gradient, which is rise divided by run. So my rise is 15, my run is 12. So that's me setting up the fraction. I've obviously got a calculator, pop it in, and then that is my daily rate. So I'm paying £10 and then £1.25 every day after that. Now, this is where I think it really does get quite tricky. Knowing how to approach this question isn't always obvious. So you're being told about saws to you, who are going to just charge £3 every day of the hire. And it says that we're going to be hiring for different periods of time, and we want to find the cheaper company. Which of the two companies is the cheaper to hire the chainsaw from? And you must show and explain your answer, okay? It doesn't say how many days, it just says, and I'll highlight, it just says she wants to compare the cost. So if we think about it, even without the graph, if we think about £3 a day, then for one day, it's going to cost £3. The other place was going to charge us £10 before we even started. So straight away, that one feels cheaper. But in the long run, what happens? So really, the best way to approach this is to try and draw a picture of the new information that we've got. So we know from that new information that it's £3 a day. So what I chose to do here was pop a coordinate on that says it's 0, 0, 0 days, no cost at all. After 10 days, it's going to be 30 because 3 times 10 is 30. And then I just drew a straight line through that and had a good look at where it was crossing. And it was crossing just before that 6-day period. So I made the observation that saws to you are cheaper if you're hiring for 5 days or less. It's worth paying just £3 a day if it's £5 or less. But once you're over that 5 days, it's going to be more expensive. So you'd be better off if you know the job is going to take you longer than 5 days to go with the original company. Okay, they are tricky. I will hopefully find more so that they dot about in various different videos so that you kind of get used to seeing that type of thing. So that's it for this particular session. Really, really well done. I will keep doing them so that you can get yourselves fully prepared. I can't get my words out today. Thank you for joining Target Maths for your revision. I hope you are finding them helpful. Feel free to subscribe because they are popping up a bit randomly as and when I've got time to make them. And I will see you next time.